Okay, so in this video, I wanted to talk about inverse trig functions, and in particular, we're not going to get too advanced with this topic. I'm only going to use it to figure out the angle, the unknown angle, if we have a right triangle. So the angle will be between 0 and 90 degrees, or 0 and pi over 2 radians. Okay, but we need to learn this idea about inverse trig functions so that we can figure out the particular angle. So as you know, right, the sine, cosine, and tangent functions are definitely not one-to-one, right? So in this first picture here, I have a graph of the sine function, and of course it oscillates forever, right? To the right and to the left, from negative infinity to positive infinity. So since it's not one-to-one, it doesn't in general have an inverse. Remember, inverse, in order for a function to have an inverse, it has to be a one-to-one function. So what we can do is we can restrict the domain. So in this case, what I did was I restricted the domain of the sine to be just between negative pi over 2, so right here, and pi over 2. So just this red section. And that section is one-to-one, right? It passes, first of all, it's a function, right? So it passes the vertical line test. In fact, the original sine function is a function as well. But in this case, it also passes the horizontal line test, right? If I draw a horizontal line anywhere through that little red piece, it's only going to intersect the graph once. So between negative pi over 2 and pi over 2, it does have an inverse, okay? So if we restrict the domain of our trig functions, then at least over that particular domain, the function will have an inverse. Now, let me show you the other. So this is the one for sine. Now for cosine, it would look like this. Okay, so here's cosine, right? So that's the general cosine function, which of course is not one-to-one, but if I restrict it to be from, and this is sort of arbitrary, but this is sort of an agreed upon choice, like most textbooks use these particular domains. So I'm restricting it now to be between 0 and pi, and in that case, so this red curve here, over that domain, it is one-to-one, right? It passes the vertical line test, so it's a function, and it also passes the horizontal line test, so it's one-to-one. So we'll have an inverse over that particular domain. And then the tangent looks like this. Okay, so here's a graph of the tangent function. Now remember, the tangent function has these vertical asymptotes, right, at, pi over 2, and then 3 pi over 2, 5 pi over 2, and so on, and then negative pi over 2, negative 3 pi over 2, and so on. And again, as a whole, this function is not one-to-one, because if I draw a horizontal line, it's going to intersect many, many, many different places. In fact, an infinite number of places. However, if I restrict the domain to just be between negative pi over 2 and pi over 2, so just this red curve, then the tangent function is one-to-one and will have an inverse, right? Okay, so all right, so let me summarize this. So for angles, in the interval negative pi over 2 to pi over 2, if sine of theta is equal to some value a, remember a can be between negative 1 and 1, right, over that particular interval, then, and this is how we write the inverse sine function, then sine to the negative 1, that you would read that as inverse sine of a, right, of the output, gives you back the input, which is the angle. So we use the inverse functions to give us back the angle. Now, so that's for sine. For cosine, So for angles in the interval, in this case, remember we decided to use 0 to pi. If cosine of theta is equal to a, then at least over that interval, right, where it's 1 to 1, if I apply the inverse cosine function to a, I'm going to get back my angle theta. Okay, and then for tangent, so for angles in the interval, in this case I've used parentheses because remember it's undefined. There's a vertical asymptote at pi over 2, negative pi over 2. So from parentheses negative pi over 2 to pi over 2, if tan of theta is equal to a, then the inverse tangent of a will give me back theta, right? And the angle will be in that interval. Okay, another way of saying this, and we can talk about like the domain and range of the inverse functions. Let me do this on the next page. So the inverse sine function, I'll just say of x in general, has domain. So now the input can be between -1 and 1. And then the output in the range here is going to be our angle, right? But remember, the output has to be between negative pi over 2 and pi over 2. So the range is going to be between negative pi over 2 and pi over 2. And by the way, sometimes instead of saying inverse sine, we call this the arc sine. So another name for inverse is arc sine of x. Now with cosine, so inverse cosine of x has domain again -1 to 1, right? Remember, so like -1 to 1 are what the possible outputs of the regular sine and cosine functions would be. So those are going to be the inputs, right, to the inverse functions. Like the -1 to 1 were the ranges of the original functions. So now they're going to be the domains of the inverse function. In this case, it's going to have range 0 to pi. And another name for that inverse function, so inverse cosine, is also called arc cosine of x. And then for the tangent, so arc tangent or inverse tangent of x has domain in this case -infinity to infinity, and range is going to be negative pi over 2 to pi over 2. Right? Those are the possible angles that would be the output of the arc tangent function or inverse tangent function. And again, arctan, and then the name for that, or inverse tan, another name for that is arctangent. So arctan of x. Okay, now basically for what we need the inverse functions for, we could get more involved. I could do more involved questions, but I just want to focus on finding the unknown angles of right triangles. So if you think about it, let me go back to the pictures in the beginning. So here's my sine function, right? And remember, the red is going to be the restricted sine function. So that's the domain where I make it 1 to 1. So if that's the case, what does the actual inverse function look like? Well, let me plot that. Okay, so the red here, the red graph here, this is my sine function, right? The restricted sine function just from negative pi over 2 to pi over 2. The purple dashed line is the identity line, right? That's y equals x. And then remember, the inverse function graphically is going to be a reflection about that line. So in this case, the blue curve here, this is my inverse sine function, or my arc sine function. And notice that the input, right, to the inverse function, the arc sine, can be between -1 and 1, right? That was the same as the output of the original function, so now it becomes the input. The domain and range switch. And then the output of that blue function is going to be your angle. So it's going to be between negative pi over 2 and pi over 2. Now, in our case, since we're just going to look at the unknown angles of a right triangle, that means the angles will always be between 0 and 90 degrees, or 0 and pi over 2. So we're only going to focus on this region here, just the first quadrant, right? So it's going to be between 0 and pi over 2, depending on what the input is. Okay, so that's sine. Let's look at cosine. Okay, so again, the red is the cosine function, right? Remember, the highest point is 1. So let me point. Highest point is 1 there, and it oscillates back and forth forever. But we're just restricting the domain now of that cosine function between 0 and pi. So 0 and then pi is like 3.14, somewhere around here. So to get the arc cosine, or the inverse cosine, I can reflect that graph about the line y equals x. And when I do that, I get this blue graph here, and this is the inverse cosine, or the arc cosine function, the blue. And again, since we are going to focus just on unknown angles of right triangles, we only have to worry about what's happening in this first quadrant here, right? So when the input of the arc cosine is between 0 and 1, then the output angle is going to be between 0 and pi over 2, or 0 and 90 degrees. Okay? Think about it. It makes sense, right? If the input is a 1, then the output to the arc cosine is 0, right? What that's saying is cosine of 0, cosine of the angle, equals 1. If the input was 0, the output is pi over 2, or 90 degrees. So what is that saying? It's saying if you did the cosine of 90 degrees, you would get 0, right? You can always flip it around the opposite to make sure that it's making sense. Okay, and then lastly, let me just plot the tangent and inverse tangent. Okay, so again, the red graph was the tangent function, right? And it was restricted to be between negative pi over 2 and pi over 2. And then if I flip that about the line y equals x, then I get this blue graph here. So here's my blue graph, and that is my inverse tangent function, right? It's my arc tangent function. Remember, in this case, the input could be between negative infinity and infinity, and the output is going to be an angle between negative pi over 2 and pi over 2, or negative 90 degrees and positive 90 degrees. And again, since we're only going to focus on the unknown angle of a right triangle, we only have to worry about what's going on in the first quadrant. So now in this first quadrant, the input could be between 0 and infinity, and the output stays between 0 degrees and pi over 2, or 0 degrees and 90 degrees. let me actually go back and give you a couple of examples, a couple of points that you guys know, just so that make sure that this makes sense. Okay, so I'm back with the sine function and the inverse sine function. So let's look at a couple points just to make sure this all makes sense. Let's say I want to know the sine of pi over 2, right? Which is equal to the sine of 90 degrees. Well, if I go to the input here, right, if I go to pi over 2 or 90 degrees, so right now this is in radians, right? So I'm going to really do pi over 2. Well, pi over 2 is like 3.14 divided by 2, so it's like 1.6 something, so it's like right here. That would be the input. And what's my output? Well, it'd be this value right here, which if you look at this, this is equal to 1, right? This value should be exactly 1. So this is going to be equal to 1. Let me go back and do this in black. 1. Okay, so that means if I do the inverse sine or arc sine of 1, what should I get back? I should get back pi over 2, right? Which is, again, 90 degrees. It depends on whether you're doing in radians or degrees. So if you go to the blue graph now, if my input is 1, which is here, what's my output? It's pi over 2, right? So it just reverses. Okay, let me do the same thing for cosine. Okay, so let's say I'll use 0, right? We know that cosine of 0 radians, which is equal to cosine of 0 degrees, that's equal to 1, right? And we can see that in the graph right here. Remember, it's the red graph. If my input is 0 to cosine, my output is going to be, this is exactly equal to 1 there. So this is 1. So therefore, if I do the inverse cosine or the arc cosine of 1, I better get back 0, right? So in this case, if you look at this, if I do the inverse cosine, which is the blue curve, of 1, what do I get back? I get back 0, right? I get that point right there. So it's exactly on the point 1, 0. Look at the other extreme. Let's say I do cosine of pi over 2, which is the same as cosine of 90 degrees. Well, remember, that's equal to 0, right? And we can see that on the graph right here. If my input is pi over 2, my output is going to be 0, right? So now if I flip it around and I do the inverse cosine, or the arc cosine of 0, I should get back pi over 2. And if you look at this blue curve, that's exactly what we get, right? If the input to the arc cosine or inverse cosine is 0, what's my output? My output is pi over 2, or 90 degrees. Okay, and the same thing for tangent. So if cosine of A equals B, then arc cosine of B gives you back A, right? Just like any regular inverse function would work, except we have to be careful here. We have to restrict our domain. Okay, so let me do some examples now where this would come into play. Again, especially thinking about right triangles where we have an unknown angle. Okay, so for example, let's say this is my right triangle. So this would be my right angle. let's say this is my angle theta that I don't know, it's unknown. Let's say I know this length 10 and I know this length 3. Okay, and I want to figure out the measure of that unknown angle. By the way, I could find this side, right? I could also find this side if I wanted to. How would you do that? Well, the easiest way to do it would just be use Pythagorean theorem, right? Because it's a right triangle. So I know that 3 squared plus whatever that side, call it x squared equals 10 squared, and we could solve for that side. So often you use the Pythagorean theorem to find an unknown side if you have a right triangle. But in this case, I want to find that angle, the angle theta. So relative to that angle, the 3 is opposite, right? The 3 is opposite that angle, and the 10 is the hypotenuse. So what trig function relates those together, opposite and hypotenuse? That would be sine, right? So I know that sine of theta is equal to the length of the opposite side over the length of the hypotenuse. But I don't want sine of theta, I want the angle theta. So how do I do this? How do I actually extract out that angle? Well, what I would do now is take the inverse sine of both sides. So if I do inverse sine of theta, and whatever, do one side after the other side. So I also want to do inverse sine of 3/10 on the right-hand side. Okay, why am I doing this? Because remember, if you do the inverse function of a function of x, right? If you do that composition, you get back the argument x. So if I do inverse sine of theta, it's going to give me theta, right? So I'm extracting out theta, right? That's all I have left on the left-hand side. What about the right-hand side? Well, this is what you'd have to plug into your calculator. And then depending on whether you want the angle in radians or degrees, let's say we just want it in degrees now, so make sure your calculator's in degrees. This is going to be around, and you have to round it a little bit, around 17.5 degrees. So it's saying that that angle is 17.5 degrees. Now, how would you check this, right? Well, what you could do is you could plug this back in, right? If we do, so to check, I'll do this in red. If I do sine of 17.5 degrees, I had better get back out 3/10. Or something very close. You're going to get around 0.3, right? Because there's a little bit of rounding error here, but you'll get something very, very, very close. Okay, here's another example. Let's say that here's my right triangle. Okay, so that's the right angle. Let's say this is my angle that I don't know. I'll call it phi. And this length is, say, 8, and this side is, say, 5. And I want to figure out what phi is. Okay, so relative to that angle, what do I know? Well, I know the 5, which is opposite, right? The 5 is opposite the angle. The 8, which is adjacent, right? It's next to the angle. And I don't know this side, which is the hypotenuse, but I could get that side, and the easiest way to find that side would be to just use Pythagorean theorem. Okay? But we're not worried about that right now. Let's say we just want to figure out the angle phi. Okay. So again, I know the opposite and I know adjacent. So what trig function relates opposite and adjacent? So TOA, so I guess tangent, right? TOA is opposite over adjacent. So tangent of phi is going to be the length of the opposite side divided by the length of the adjacent, so 5/8. But I don't want tan phi, I want phi, I want the angle phi. So how do I extract out the angle? Well, I need to do the inverse tangent of both sides. So the inverse tan of phi is just phi, right? I get back that argument phi, which is what I want. And then the right-hand side, you have to plug this into your calculator and make sure you're in degrees for this particular problem, and you're going to get 32.0 degrees. And then to check it, if you do tan of 32.0 degrees, you should get back around 5/8, right, which is 0.625. So you should, or 6, I wrote that in reverse, 625, right? Yeah. So you should get something very close to 0.625 if you plug in 32 degrees now. All right, so actually that's all I want to do for the inverse trig function. So you're only going to need them to find the unknown angle of a right triangle. All right, the next thing I want to discuss is vectors and how vectors work. So that'll be the next video lecture. Thanks.